Welcome to the DIY Honda Garage channel. The DTC P0453 indicates a high voltage condition in the fuel tank pressure FTP sensor circuit for the Honda Odyssey models from 2011 to 2017. This DTC essentially means that the engine control module, ECM, has detected a voltage reading from the FTP sensor that exceeds its normal operating range. The FTP sensor is a vital part of the evaporative emission control system, EVAP, which helps the vehicle manage fuel vapor to reduce emissions. The sensor is typically located near the fuel tank and monitors the pressure within the tank. If the FTP sensor is malfunctioning, or if there are issues in its circuit connections, it could lead to erroneous data being sent to the ECM. Addressing this trouble code is essential for ensuring proper vehicle performance and compliance with emission standards. The DTC P0453 typically involves the FTP sensor, an integral part of the evaporative emission control system, EVAP. This sensor is responsible for monitoring the pressure in the fuel tank and sending this information to the engine control module, ECM. Its primary role is to detect vapor pressure fluctuations that could indicate leaks or other issues within the fuel system. The FTP sensor is usually situated near the fuel tank, making it accessible for diagnostic checks and connections. If the sensor reports a voltage that is too high, it can trigger a fault in the ECM, leading to potentially increased emissions and decreased engine performance. Additionally, any damage to the wiring or connections leading to the FTP sensor may also impact its functionality. Several potential causes may trigger DTC P0453. A faulty FTP sensor is often the primary culprit, as it can generate incorrect voltage readings due to internal failures. An electrical short circuit in the wiring that connects the FTP sensor to the ECM can also lead to high voltage readings. This could occur due to damaged insulation or bare wires that make contact with metal parts, creating unintended paths for current. Additionally, loose or corroded connections at the FTP sensor or within the wiring harness can also cause inconsistent voltage readings. Each of these components must be carefully inspected to ensure a proper resolution of the trouble code. When experiencing DTC P0453, several symptoms may manifest in the vehicle's operation. Firstly, the check engine light will illuminate on the dashboard, alerting the driver to potential issues within the emission system. The vehicle may also experience poor fuel efficiency, as the ECM may alter fuel delivery to compensate for perceived conditions in the fuel tank. Rough idling could be another symptom, as the engine will not operate smoothly if it receives faulty information from the FTP sensor. Additionally, drivers may notice unusual engine performance issues, particularly during acceleration or deceleration. Recognizing these symptoms early can help prevent further damage to the vehicle. The first step in troubleshooting DTC P0453 involves turning the ignition switch to the on position, which can also be accomplished by pressing the engine start-stop button. This prepares the vehicle's electronic systems for diagnostic checks and ensures that the engine control module, ECM, is active and can communicate with diagnostic tools. It is crucial to perform this step before making any further checks or adjustments to the vehicle, as it allows the system to engage its various sensors, including the fuel tank pressure, FTP sensor. During this stage, no engine cranking is required. Simply ensuring the ignition is on is sufficient for initializing the diagnostic process. Next, utilize the Honda Diagnostic System HDS to clear the previously set DTC from the vehicle's memory. This action will reset any fault codes that were logged and is essential for starting fresh diagnostics. Clearing the DTC allows the technician to monitor the vehicle's sensors and systems without the interference of old fault codes. After clearing, It is essential to observe the system's response, as it can provide vital clues regarding the condition of the FTP sensor and its associated circuits. Properly executing this step sets the stage for accurate diagnostics by ensuring the latest data is being reviewed. After clearing the DTC, turn the ignition switch to the lock position or press the engine's start-stop button to select the off mode. This step ensures that all electronic systems are completely powered down before proceeding with further diagnostics. Turning the ignition off is essential to prevent any disturbances in the FTP sensor circuits while making physical inspections or adjustments. This also allows the technician to ensure that all settings are reset in the vehicle's memory. After turning off the ignition, allow a brief moment before moving on to subsequent steps in the diagnostic procedure. The next step involves removing the fuel fill cap. This action alleviates any pressure within the fuel tank and allows for a more accurate assessment of the FTP sensor and its circuits. It is essential to perform this step to ensure safety while working on the sensor, as well as to avoid potential inaccuracies during testing. By relieving the fuel tank pressure, it allows for the sensor to function within its normal parameters. This action should be conducted carefully, as fuel systems can be sensitive and require appropriate handling to prevent spills or leaks. After removing the cap, prepare for the next steps that involve monitoring the sensor's output. Turn the ignition switch back to the on position, either by using the ignition switch or the engine start-stop button. This action reactivates the vehicle systems, including the fuel tank pressure FTP sensor, allowing it to provide live data for diagnostics. This step is critical for checking the FTP sensor's output, ensuring that the engine control module, ECM, can read the sensor's feedback accurately. Keeping the fuel fill cap off during this process may help the sensor provide a more stable reading without pressure variances affecting its output. It is essential to monitor the information displayed on the HDS closely after taking this action. Utilizing the HDS, check the data from the FTP sensor. You should expect to see a value indicating about 7.3 kilopascal, which translates to approximately 2.16 inch flange, or 55 millimeters inch egg. Alternatively, the voltage should read 4.7 volts or more for proper functioning. This verification process is vital for determining the health of the FTP sensor. If the readings fall within acceptable ranges, it indicates that the sensor is functioning correctly, and further diagnostics should be conducted to investigate wiring and connections. Should the readings be outside these parameters, this may confirm the need for further action, potentially replacing the faulty FTP sensor. Monitoring the output against normal specifications is a key factor in resolving the DTC. After checking the FTP sensor data, it is crucial to reinstall the fuel fill cap securely. This ensures that no fuel vapors escape and that the tank can maintain proper pressure while the engine is running. Reinstalling the cap is an important step that helps in creating accurate conditions for engine diagnostics. Without a proper seal, the vehicle may exhibit symptoms of erratic sensor performance, including potential misreadings of the FTP sensor. After securing the cap, the next step will be starting the engine and monitoring the OBD status. It is important to ensure that all components are back in their original positions before moving on to the next diagnostics. Start the engine and allow it to idle to create normal operating conditions for the FTP sensor. This step is essential as it allows the engine control module, ECM, to evaluate the FTP sensor's performance while the engine is running. During this idle period, the ECM can monitor various parameters, including fuel pressure and emissions, to ensure that everything is functioning as intended. It is crucial that the engine is running at optimal idle conditions to capture accurate data for diagnostics. If an issue exists, it may be reflected through abnormal engine running or changes in the monitoring results. Allowing the engine to idle is an important phase for the eventual validation of the FTP sensor's integrity and output. During this step, utilize the HDS to monitor the onboard diagnostics (OBD) status for DTC P0453. The goal is to check if the HDS indicates that the system has failed or passed. If the status displays as failed, the diagnostics will continue to the next troubleshooting step. Conversely, if the status shows passed or intermittent failure, it suggests that the system could be functioning correctly at that moment in time. While this might indicate that no immediate faults are present, it is advisable to check for poor connections or any loose terminals at both the FTP sensor and the powertrain control module, PCM. If the status indicates not completed, keep idling the engine until a definitive result is available. This process aids in ensuring the monitoring of all systems before a fault can be declared. With all previous steps completed, turn the ignition switch to the lock position or use the engine start-stop button to power down the vehicle's systems. Switching to the lock state is necessary before disconnecting any components to ensure that no unintended shorts or electrical issues can occur while working on the FTP sensor. This preparation step is crucial for the safety of both the technician and the electronic components. Allowing the vehicle's systems to completely power down is essential when proceeding to check connections or perform any further diagnostic procedures on the FTP sensor itself. After ensuring the ignition is in the lock position, prepare to disconnect the FTP sensor for further examination of the circuit. The next step requires disconnecting the FTP sensor's 3P connector. This action provides access to the FTP sensor's terminals, allowing for more in-depth diagnostics of the wiring and connections. When disconnecting the connector, it is essential to handle it gently to prevent any damage to the pins or terminals that could lead to additional complications. Once disconnected, this allows you to examine the connection for any signs of corrosion or wear that could potentially lead to faults. Disconnecting the sensor is critical for ensuring that subsequent tests will yield accurate results. Once the connector is safely removed, proceed to the next step to evaluate the sensor's functionality and test the circuit integrity. In this crucial step, connect terminals number 1 and number 2 of the FTP sensor 3P connector with a jumper wire. The jumper wire serves to create a temporary direct connection that bypasses the sensor itself, which enables diagnostics of the wiring and ensures that the issue is not due to sensor failure. It is essential to ensure that the jumper wire is secure and that it does not make contact with any metal parts to avoid shorts. This setup allows for monitoring the voltage reading from the FTP sensor, establishing a baseline for the system's performance. Proper execution of this step is pivotal in identifying whether the wiring is intact and whether the fault lies within the sensor or the circuitry leading to the PCM. Once the jumper wire is securely connected, turn the ignition switch back to the on position, either via the ignition switch or by pressing the engine's start-stop button. This action will re-engage the vehicle's electronic systems, allowing the engine control module, ECM, to read values from the FTP sensor corresponding to the jumper connection. It's important at this stage to monitor how the system responds to this test condition, as this will provide insight into whether the wiring integrity is intact. After switching the ignition on, observe the data that the HDS provides in regard to the FTP sensor to assess the situation. This step is critical for further validating which aspect, be it the sensor itself or the wiring, is contributing to the DTC. As the final diagnostic measure, check the FTP sensor data using the HDS again after the jumper wire connection. You should expect to observe similar values as indicated before, specifically around 7.3 kilopascal, or approximately 4.7 volts or more. If the readings align with these figures, it suggests that the wiring leading to the FTP sensor is functioning correctly, confirming that the high voltage condition originates from a faulty FTP sensor. However, should the readings differ from these expected values, replace the FTP sensor as it has likely failed. This diagnostic procedure will ultimately determine the root cause of the DTC P0453, enabling appropriate repairs to proceed. After completing the repairs, it is essential to verify that the issue has been resolved. Start by clearing the DTC P0453 using the HDS. Then perform a test drive to confirm that the condition no longer reappears. Monitor the vehicle's OBD status during the drive to ensure that no new DTCs are triggered. If the vehicle operates smoothly without the check engine light reactivating, this indicates that the repair was successful. Additionally, verifying that the FTP sensor is functioning within specified parameters during the drive reassures the technician of the system's integrity. This complete breakdown confirms appropriate handling of the DTC and validates the effectiveness of the performed repairs. To prevent future occurrences of DTC P0453, it's important to establish a schedule for regular maintenance checks of the FTP sensor and its connections. Inspecting the FTP connections for corrosion, wear, or loose fittings can significantly reduce the likelihood of future issues. It is also essential to monitor the vehicle's performance regularly and address any signs of unusual operation early before they escalate into larger problems. Properly securing the wiring can prevent failure caused by chafing or shorts. Keeping the EVAP system in good working condition through consistent maintenance practices ensures that the vehicle continues to comply with emission standards while operating efficiently. Consistent preventive measures are crucial for the longevity of your vehicle. In summary, DTC P0453 signals a high voltage condition from the FTP sensor, potentially leading to impaired engine performance and higher emissions. Understanding the FTP sensor's role in the evaporative emission control system is critical for diagnosing issues accurately. Following the outlined troubleshooting steps thoroughly ensures that any faulty components, whether they are the sensor itself or related wiring, are addressed effectively. Regular preventive maintenance around the FTP sensor and its connections can help mitigate the recurrence of this error code. Ultimately, a concise understanding of diagnostic procedures will empower technicians to maintain the vehicle's operational integrity and emissions compliance. Proper execution of these preventive measures significantly enhances vehicle performance and lifespan. Please like and subscribe to the channel. See you next time.